Boiling beneath the ice. Secrets of the solar system's wildest oceans. Hey there, space explorers. Imagine this. Beneath a crust of ice colder than anything on Earth, vast oceans bubble and boil like cosmic cauldrons. We're talking about the icy moons of our outer solar system, worlds like Enceladus, Miranda, and Mimas. These aren't frozen tombs. They're dynamic, explosive hotspots where hidden waters rage against their icy prisons. Today, we're diving into the mind-bending science behind these subsurface seas, straight from the latest breakthroughs. Buckle up, it's going to get steamy. Let's start with the superstar, Enceladus, Saturn's pint-sized powerhouse. This moon is just 500 kilometers across, about the size of Texas, but it's punching way above its weight. Back in 2005, NASA's Cassini spacecraft flew by and spotted something wild, geysers erupting from its south pole. These plumes shoot water vapor, ice particles, and even organic molecules thousands of kilometers into space. Scientists call those cracks the tiger stripes, 4 massive fissures, each over 100 kilometers long, spewing like Earth's Old Faithful on steroids. But here's the kicker. New research from just last week, March 2, 2026 to be exact, reveals Enceladus might have boiling oceans right now under its ice. How? Tidal heating. Saturn's massive gravity, plus tugs from nearby sister moons, squeezes and stretches Enceladus like cosmic dough. This friction generates insane heat deep inside. The ice shell, 20 to 28 kilometers thick on average, melts from below when heating ramps up. As it thins, pressure on the ocean drops suddenly. Boom, the water hits its triple point around 0 degrees Celsius. That's where ice, liquid, and vapor coexist. The ocean boils. Picture frigid water, around 0 degrees C or 32 degrees F, turning to steam without getting hotter. Cassini data backs this up. Measurements show Enceladus loses 54 gigawatts of heat total, enough to power 40 million homes on Earth. That's from tidal forces alone, matching predictions perfectly. And get this, even the North Pole, once thought dead, glows 7 degrees C warmer than expected in infrared scans from 2005 and 2015. That heat leaks from a stable, salty ocean that stayed liquid for geological eons. Life? Maybe. Those plumes carry phosphorus, a key ingredient for biology. Enceladus isn't just active, it's a potential ocean world screaming habitability. Now shift gears to Saturn's quieter neighbor, Mimas. You know it as the Death Star moon, thanks to that giant crater. But new models say its subsurface sea could be boiling too. Same tidal trick. Ice melts, pressure plummets, vapor forms. On these small moons, the effect is huge because their shells are thin, maybe just tens of kilometers. No plumes spotted yet, but those weird surface wobbles could be steam pockets reshaping the ice. Hop over to Uranus, the ice giant with its wonky flock of moons. Miranda steals the show here. Voyager 2 zipped by in 1986, snapping pics of chaos, cliffs taller than Everest at 20 kilometers high, and bizarre coroni, giant, ridged donuts scarring its surface. Scientists puzzled over them for decades. Enter the boiling ocean theory. As Miranda's ice shell thins under tidal stress from Uranus and its moon neighbors, the hidden sea boils at 0 degrees. Steam surges up, fracturing the ice and sculpting those coroni. Recent simulations from UC Davis confirm it. Pressure drops hit the triple point exactly on moons this size. Miranda's no slouch either. It's tiny, 470 kilometers wide, but evidence points to a past or present ocean. Stress fractures scream recent activity. One study even suggests its interior stayed warm enough for liquid water surprisingly late, maybe as recently as 1 billion years ago. Not what you'd expect from a rock that should have frozen solid eons back. And don't sleep on Ariel, another Uranian moon. Researchers at the University of North Dakota mapped its craters and ridges using Voyager data. Their models? A massive subsurface ocean once made up 55% of Ariel's volume, 170 kilometers deep. Picture that. A sea thicker than Earth's deepest ocean trench, sitting atop a 740-kilometer wide core, all under a 30-kilometer crust. Tidal tugs from Uranus and sibling moons cracked it open, forming the features we see. Caleb Strom, the lead scientist, says it means ocean worlds might be easier to make than we thought, even on tiny moons. What ties this all together? These moons orbit gas giants where gravity games run wild. Orbits shift, heating pulses, shells thicken and thin like breathing lungs. When freezing bulks up ice, pressure builds, cracking tiger stripes. When melting thins it, boiling ensues, blasting vapor to the surface. Paul Bion, a planetary geophysicist, notes this could explain how ocean goodies reach the top. Gas bursts punch through, maybe carrying clues to alien life. We've sent orbiters like Cassini, flybys like Voyager. Future missions: NASA's Europa Clipper launches soon to Jupiter's icy moon, same vibes. ESA's Juice heads to Ganymede. But Enceladus and Uranus moons beg for return trips, landers to sniff plumes, drills to pierce ice. Imagine submersibles in boiling seas. These worlds challenge everything. We thought icy moons were dead relics. Nope, boiling, erupting, evolving. Max Rudolph, the UC Davis geophysicist behind the new boiling models, calls it remarkable. It reshapes how we see ocean worlds. And here's the mind blower to leave you staring at the stars. On Enceladus, that stable ocean has churned for billions of years, heated just right by Saturn's pull, emitting more energy than 100 nuclear plants combined. If life sparked there, it could be thriving right now, in a boiling sea under ice we can see with backyard telescopes. Our solar system isn't done surprising us. What's bubbling next? Keep looking up.